Okay, so now we're moving on to some of the more fun stuff, actually getting to solve some of these problems. The first problems we're going to look at is exponential equations. We're going to solve different types of problems of exponential equations, and then we'll move on to logarithm equations, which will probably be a separate video, just given the fact that I think this one might take a little bit of time. So, there are two ways that we could solve these exponential equations. They're outlined here. The first method, which I'll just call method 1 just for the sake of this video, is writing them so that the bases are the same. Notice, of course, if b to the x power equals b to the y power, that means that these bases are the same. And if the bases are the same, that must mean the exponents are the same as well, thus that they're equal to each other. So an example of this, if I said 2 to the x power was equal to 2 to the y power, well, that would, of course, imply that x is the same thing as y. Because if it ends up being 2 to the 4th power, then the other one would also have to be 2 to the 4th power, so they would have to be equal. Okay. The other method, method 2, which is more of my go-to method, is when you put a logarithm on both sides. Doing this and then using kind of just your standard algebra techniques to finish evaluating problems. Now, method 1's a really, really good method. However, it takes kind of an insight into a certain pattern of numbers that you need to know. If you don't, recognize these numbers, it's going to be hard for you to do it using method 1. That's why method 2 is my go-to, because sometimes, you might struggle a little bit trying to figure out what numbers to use for method 1, and method 2, you don't really have to worry about that. You just kind of do your simple algebra steps. So let me show you an example of what I'm talking about. Before I get to that example, though, I'm going to show you kind of what the pattern of numbers you kind of need to know or be able to recognize to do it method 1 way. So here's a kind of a list of numbers that you want to get yourself familiar with. So powers of 2 are 2, 4, 8, 16, 32, and 64, etc. And this is because 2 is 2 to the 1st power, 4 is 2 to the 2nd, 8 is 2 to the 3rd, 16 is 2 to the 4th, etc. Right? And this goes on for the powers of 3 as well, 3 to the 1st, 3 to the 2nd, 3 to the 3rd, and those go on. Same for 4 and 5. So those are the list of numbers that you'd have to be able to recognize to do that first method. So let me show you this first example. Okay. So our first example, 8 to the x power equals 2 to the x plus 6 power. Now using method 1, remember method 1 was claiming b of x equal b of y. So you'd have to have the same base, right, for x to be the same as y, for the exponents to be equal to each other. Now, the obvious issue here is we don't have the same base, right? 8 and 2 are clearly not the same number. But the thing that you've got to figure out is, can you write 8 as a number with a base of 2? And that's where you'd go back to this list. And you'll see that 8 can be written as a value or a number with a base of 2, right? Because 8 is the same as 2 to the 3rd power. So that's what we'll do. If we're going to try method 1, which I'll do first, I'll do both methods here. Just so you can see if method 1 is your method, how you do it the other way. But I'm going to change 8, I'm going to rewrite it as 2 to the 3rd power, because 2 to the 3rd power is the same thing as 8. Equals, of course, 2 to the x plus 6. I didn't do anything to the right side. Just to clean up the left side a bit, this would be 2 to the 3x power, right? Just putting the exponents together. Equals 2 to the x plus 6. Now you realize, hey, I've got the same base, right? That must mean that these exponents are the same, thus that their exponents are equal to each other. So that would mean 3x is equal to x plus 6. And now we have just a simple little algebra problem. Let's move the x over to the left side. So we can have, let's see, 3x minus x would be 2x. Equal to 6, so I just combined my x terms together, and I had to move one to the other side to do that. But now, I've got 2x equals 6, I'll divide by 2, and I get x equal to 3. Right, and if you want to, you can plug that 3 in and see that it works. Okay, so that's method 1, and the hardest part about this method is the very first step. Being able to see that you can change 8 into 2 to the third power. That just takes some getting used to. It takes a lot of familiarity with, these lists of numbers here to really kind of see that. So that's why I provided this list. I think it's helpful if you write all of these in. I'm not going to do that just for the sake of the video, but if you make this list at home, you can do it and fill them all in. All right, method 2 though. So I'll put it over on this side, I guess. Method 2. Method 2 is where you just put logarithms on both sides. So let's start with the problem 8x equals 2 to the x plus 6. If you're going to use the second method, then you're just going to throw logarithms on both sides. So call this log 8 to the x equals log 2 to the x plus 6. So all I've done is really just write log on both sides. But that helps a little bit because now we're using the properties of logarithms. One of the main properties that we talk about is having exponents. And we never really like to have the exponents sitting where the exponents sit. We typically like to move them to the front. It'll make things a little bit easier in the long run. So let's move those exponents. Let's move x to the front of this logarithm, be x times log 8, and then we'll move x plus 6 to the front of this logarithm. Now I'm putting in parentheses because x plus 6, it does go together. It is one thing. It's one piece. So those x plus 6 is kind of stuck together, so I put them in parentheses because they go together. All right, now I'm using kind of just standard algebra rules. So I want to combine these logarithms. I want to try to evaluate these logarithms, but they're on opposite sides. So I have to either move the log of 2 over to this side, or I can move the log of 8 over to this side. It doesn't really matter which one you do, but just a standard rule of thumb, it's easier to move the smaller one because you're going to more likely get a favorable number that's easier to work with. So that's what we're going to do. So notice though, I'm multiplying that logarithm to that x plus 6. So to undo that, I would have to divide this logarithm on both sides, right? Because the opposite of multiplying would be to divide it. So that's why I'm dividing it. So that's going to get rid of the logarithm here. And now on the left side, I have log of 8 divided by log of 2, which is something I can just do in my calculator. So let's pull that up. Right, we could type in log of 8 divided, oops, hold on, I forgot the parentheses, divided by log of 2, and I get 3. So, really this is just going to be x times 3, so I'm just going to write this as 3x, I'm talking about this x here, right? I still have that x, but this logarithm becomes 3, so together it's 3x, and it's equal to x plus 6. And now of course you'll notice that equation is the same as this one, and of course it's going to work out exactly the same as well, and we'll get the answer that x equals 3. Alright, so either method will work. Let's do a couple other examples and kind of wrap this one up. But that's how each method would work. Okay, now you can choose which one you want to use. I will say the second method is going to be used more often than the first, because I think you'll see in this second example here that we can't actually do, well, the first method doesn't necessarily work out too well. So 5 to the x plus 2 power equals 200. Now it'd be nice if I could write 200 as with a base of 5, but if you look back at that list, you'll notice that for powers of 5, 200 does not make that list, right? We go from 525, 125 to 625. So 200 does not make the list. So method 1 would not be a very good choice because simply be very difficult to write 200 as a base of 5. So what we're going to do instead is just resort to method 2, which is just putting the logarithm on both sides. So we'll put logarithm 5 to the x minus 2 equals to logarithm 200. Okay? So the first thing is this exponent. I hate having these exponents here. They get in the way. So we're going to move that exponent to the front. So this will be x minus 2. Now keep in mind that it goes together because x minus 2 is that single exponent. This will be times log of 5 and then equals log of 200. Alright. Now I want to combine these logarithms. I'm going to divide by the log of 5 since I'm multiplying by the log of 5 to move it to the right-hand side. So now I'm going to have x minus 2 equals, and whatever log 200 divided by log of 5 is. So give me a moment to do that. Now, I think it's a decimal, but that's okay. Log of 200, close parentheses, divided by log of 5. And we get 3.29. So we'll just use that. Equals 3.29. All right, and we'll just, well, all I have left to do is add 2 to both sides. And when I do, I get x equals to 5.29. Right? Or roughly equals 5.29 because I rounded. So that one was a little bit more straightforward. It just, like I said, it gets used to doing this whole division logarithm thing. But after a few examples, it sort of becomes second nature. You get kind of the hang of it. All right. So this is the last one I'll do in this video, just to keep it short. There's I think 3 other examples. I'll do them in a separate video, just so you can see them as more practice. But this one, now you can actually use either method you want here. If you're going to use method 1, so your idea would be to try and see if you can write 27 with a base of 3, so that those bases could match. And if you go back to that list, you'll see that for powers of 3, 27 is on that list. 27 can be written as 3 to the 3rd power. So we're going to change that 27 to 3 to the 3rd power. So this will be 3 to 2x power equals 3 to the 3rd power. Right? Now we have them the same exact base, which means that the exponents are also equal to each other. So that's going to mean that 2x must be the same thing as 3. So now we have a real easy equation. 2x equals 3. Divide by 2, and you're going to get x equals to 3/2, or you can write that as 1.5. And that's it. So method 1, very, very fast and efficient method on that. But the hardest part was, do you know that you can change 27 as 3 to the 3rd power? That's the biggest thing. If you see that, if you go back to that list, or if it becomes second nature, it's going to make your life a little more simple. For method 2, though, if you're using the other method where you put logs on both sides, this would be log 3 to the 2x power equals log of 27. Well, if you're doing it this way, we'll move the exponent to the front. This will be 2x times log 3 equals log 27. And then you want to move the logarithm here, so we're going to divide by this logarithm. Divide by log 3 on both sides. And this becomes 2x. And if you type this in the calculator, log of 27 divided by log of 3, you get that equal to 3. So you still get the same equation, 2x equals 3, and you still get the same answer, 3/2 or 1.5. So either works. Like I said, this method's my go-to if, in fact, I can't remember necessarily the 3 to the 3rd power thing. So go with what you know, okay? Go with what you know. I would like I said, this logarithm method, method 2's, kind of when in doubt, just use that. But if you remember, if you can, try method 1 because it's obviously a lot faster. All right, I'm going to cut it there, guys. I'll have 3 other examples I'll do in a separate video. We'll see you next time. Bye-bye.